of this training is just some basic. It is a 101 installation training, so just maybe some topics or some tips that will help you be more profitable in your installation. Kind of the way we'll go through some things the way Col-Met, designs and builds and packages and things like that as well. Just so that when you are in the field and you're presented with the installation of a Col-Met spray booth, then you'll kind of have a good concept of what's going on, and hopefully this training will help you out with that. So we'll go ahead and get started and move on through, possibly. So first off, I just kind of want to go through, there are different types of spray booths, right? There's what we have called industrial booths, and I'm just going to show some images of these here, because what I really want to draw attention to is that you'll see that some are very simple, some have conveyor going through them, some are quite, wide or large. Some of these booths have a structural frame, as you'll see in the lower right-hand corner with the conveyorized, and the one right above that you see, it really doesn't. It's really just a panel-on-panel type of construction. So those all things kind of do play a part when we think about installing these types of booths. Another design is a cross draft. You have from automotive to a large. You'll notice in those as well that the automotive style on the top left, not a whole lot of structural. You can see there on the booths on the right that you do have, I-beam construction. It's quite a bit larger, which, changes the way that they're installed and, hazards or concerns that you have on the installation side. Just to move through, semi-cross or modified down, same thing. We have some examples of a kind of a custom ductwork layout, pretty large booth, 42 foot wide. Obviously that booth has, some considerable structure that we would have to tend with as an installation crew. Planning for a booth like that becomes a little more important as far as lifting and, getting personnel around on top, inside the building confinements. The automotive booths at the bottom have AMUs on top with a little bit of structural frame. So just see some examples there of the different airflows and the different considerations. If you look at the booth at the top right of these side downs, a lot of building planning went involved in the installation of this. You can tell that the requirements for the booth and the space allowed were pretty tight. So it was opted that they leave off the outside wall of the building during the construction of this booth, so that there would be access to it. A lot of job sites and a lot of projects that you may find yourself on, these are things that you need to keep in mind when you show up. Hopefully you were able to see the site beforehand and maybe you're aware of some of these things. These are just some examples of downdrafts and the different types, and some installs look very simple, and you'll see that some are going to be way more in depth. So what we really want to go over in this, and just the topics that we'll cover, unloading the crates, what to see from the drawings and the bill of materials, inventory. We'll kind of go over some booth layout, which is very important when you start an installation of a bolt-together booth. Starting construction, kind of where to start, how to make that happen, and then just the process of moving on. And then we'll kind of wrap up with a review of just what we want to do and kind of what we don't want to do. So to kind of get started here, so we unload the crates. They're going to show up in a configuration probably very similar to the image there. Wooden crate, panels are stacked inside, outside with each other, banded together. If anybody's probably ever seen one of these, you go to bust them loose, they want to go everywhere. But what we would need to unload something like this off the truck or to move around a job site is, a 5,000-pound Ford truck. Hand trucks a lot of times are available and easy to use, but unloading the truck, obviously, that wouldn't work for that. Everything is crated in a manner to try to get onto a truck. So usually a 5,000-pound Ford truck is able to unload the truck. We wouldn't most definitely, guys, if we're unloading this equipment, that we need to check for freight damage or water damage. If we can notice it at this time on the bill of lading and mark it as damaged, it just expedites the whole process of either replacing that product or, nailing down what's happening, getting the right stuff there. And then, there's a lot of fighting over whose fault it was if it doesn't get signed. And it just helps you not be involved in that process at all if we notice when we unload and make note of it. There's just a couple of things that we want to consider while we're handling these things is, obviously we don't want to create damage from unloading them. We need to, pay attention if it's a wide, if it's structural and your booth is 25 foot tall, it's very, very likely that your structural members are 25 foot long. So handling those loads, trying not to drop those. Fork leaks become very important. You make sure you want to follow, a safe lifting practice with the fork truck, and that the fork is at least 2/3 the depth of the equipment that you're trying to lift. Air makeup units, set on a crate that's a little wider. A standard fork may not reach far enough across, and you don't want to risk dropping a $25,000-$30,000 piece of equipment because your forks weren't long enough. So keep in mind on that. Now, staging is something on the install side that can sometimes you luck out and you have all the room in the world, and other times you're trying to stage everything in the area that you're building that piece of equipment. And unfortunately, that works from large booths to small booths. You just, you never really know what kind of area you have. But if at all, and you have a predetermined area for staging or lay down, then, you want to try to base everything on your installation sequence. Especially if you are tight, things that you're going to need last, most installs of product doors, things like that go on kind of towards the end. First things that you need are, structural members, wall panels, things like that. So, we want to try to arrange those best we can. And we'll have a good idea of that once we kind of inventory our equipment, which we'll discuss here in a little bit. So here at Col-Met, when we load these crates, they're actually kicked back on about a 15 to 20 degree decline. So all the equipment is loaded based on it leaning to one side. If you look at the reference picture there with the crate, those are some small product doors for an automotive booth, is what that appears to be in that crate. Those were loaded first, and if you kind of look, you'll see how all the panels sort of have a slight lean towards those doors. So as they were loaded, they were just stacked in from left to right in our image, fill the crate up, they put the end of the crate on, and that crate is banded and nailed and wrapped with plastic, and then it's ready to go. So you see that the panel design there, it's hard for an installer. Any of you that's done it, you're kind of like, man, there's just panels in between everything. But the reason that's done is just for freight space, to keep the shipping costs down as low as possible, to utilize as much of the crating area that can be done. So you'll have one panel that's going to be turned legged out towards you, and then the next panel is going to sit inside of that one, and its leg will be over the top of that one. So by noticing the way that the crate is laid out, and then try to unload the crate in the exact reverse order, makes it a lot easier. If you were to take this crate in our image here and kick it and try to unload the doors first, every panel you would try to grab behind that one is going to be under another panel, right, instead of just sitting on top. So, that's a pretty good tip there as far as unloading these crates. If you can keep them kicked back on a slight angle where the panels are laying against the back, you can take the front of the crate off across the width, because that's the last thing that was actually installed on that crate. And you can just pull the panels out, right, just kind of unstack them very easily without a lot of panel weight from other stacking. So the drawings and the bill of materials are all in one of those crates. We try to mark those with the boxes you'll see in the um, picture there. And we try to, the guys, when they're going to lay them, excuse me, they're going to pack them and lay them out, where you can read it. Hopefully, it didn't shift or anything, but customer prints inside, right? So if you haven't been able to get your hands on the prints prior to this job, they will be in that box. And inside there, you'll have your approval drawings and your isometrics, your bill of materials, will all be in there in a packet. And what you'll see from the approval drawings is really just a 3 or 4 view of the booth, and it's going to show the entire booth. It's going to show any walls or roof layouts that we were aware of at time of fabrication or drafting. Depending on the project, if it is it's more of a standardized booth that's in our catalog that was ordered, it's likely that there's no building references at all. If it's a custom project that had worked through, iterations of revisions, or we're trying to fit it into a tight space, then there will be known walls or roofs on these drawings. And it's just a general arrangement of that equipment. So you would still need to know where to put it inside there from the customer or someone, but unless it was a very large engineered project, and then that would all be included in there as well. So in our isometric drawings, they're going to show our exploded construction. So we're going to actually see panel by panel, how these should go. We draw the booths in sections, and when you open your prints up, you'll see the layouts, and they're all identified as section A through however many there are, Z or so, let's call it. And then you'll have the corresponding drawings that tell you how to assemble panel by panel, piece by piece, that section. Exhaust plenums are sectionalized, and the wall and ceiling with the appropriate structure. The bill of material is really, in essence, exactly that. So what we say is what's in the drawing will be ballooned out with a number and an item number. You'll have a corresponding list of materials that'll say item number, say 1, and you'll identify what that is as far as a panel, its dimensions, and then if it's a piece of structure, it'll be identified as such. So that gives you an opportunity to not just visually see on a drawing, but actually go to a list of materials, look at that item number, and get a better idea of what's going on with that one part. Probably one of the biggest things you can do, especially before starting the install, is to kind of, pre-build this a little bit, do a little bit of thinking on it. Like I say, especially if it's a custom or a large project. And then, this is really kind of our first step in our build plan. So we just want to obviously think about what we're going to have to do, the area that we have to do it in, and kind of get our mind rolling around that while we're kind of running through these other topics here. So we want to, pardon me there, I'm jumping through, but we want to make sure that we inventory as an installer all the materials that come in. And we want to check those parts, with the BOMs and the quantities. The BOM is the bill of material. We want to check, the drawings. If there is, for some reason, an unlikely event that the drawing shows something that the bill of material does not, then that article will not be on the job site. If it is not on the bill of material, it will not be on the job site. So as we're unpacking these things and we're looking at our prints, we can identify, if in the unlikely event that we are missing something, we can identify it early in the process. Some of these items might be long lead items, which is going to lead to, delays in our project. We're going to lose work days. We're going to maybe have to make multiple trips. As an installer, these are huge monetary issues, scheduling issues that hopefully can be eliminated early in the project. Even a very small booth is going to take 1 to 2 days before it's finalized. Within 1 to 2 days, depending, unless it was some type of long lead item, that could be on the job site by the time that you would be trying to finish up. So as far as scheduling and extra days, hotel, guys setting, things like that, we can try to eliminate those things. So the question would be, is should I always inventory before construction? And the answer to that question is yes. And I will say that with the caveat that even if you don't have room, you need to do the best that you can to sort and go through panels. And the unlikely event that there is something missing, it's just helping you. Kind of go through some booth layout here. It's really probably it's maybe possibly the most important step in our booth construction. So there's a couple of ways here, and I laid out some tools and some old school ways and what I call the tech school way. You may be familiar with these, never heard of them in your life. But the old school way of kind of laying a booth out on the ground, before we start to build it, we want to build an outline on the ground that's reference marks for us as far as a straight line, a straight corner, where our booth starts, where it ends, identifying structure if we need to. That's what we're working through here. So the old school way would be a chalk line, a tape measure, a marker, of course, some sort. The Pythagorean theorem, which, let's be scientific with it there. And then, an optional framing square. If you want to try to get it right the first time or as close as possible the first time, I would recommend some type of framing square. The new way would be obviously the chalk line again, a self-leveling 5-way laser, tape measure, marker, raster square. This is personally the way that I laid out booths and equipment, conveyor lines, pretty much everything that I needed to lay out that was short enough that we didn't need a transit for. Then this is how we did it. So let's kind of walk through that a little bit. So the old school way, and would be that, obviously we're going to identify where we need our booth inside the building area on the job site. And let's say it's from a wall. We're going to normally set 3 foot from a wall. So we would take, and our booth is running parallel to the wall. We want to measure off that wall our 3 foot. And we're going to snap a line, a little bit longer than what we know our booth's going to require. Like I say, a special note on that is we always want to try to use inside dimensions when possible. The print will always identify inside dimensions. It'll identify outside dimensions as well, but as the booth is constructed, the interior dimensions are our, as a design, the critical dimension. A piece of material may end up being an 1/8 inch wider or longer than what built because of tolerances and things like that. But the inside will always be exact. So if we lay out to the inside, we got a good line reference. We can still see it even when the booth is erected. If we lay it out to the outside dimension and we have this growth in material or, something along those lines, then because some of those are nominal dimensions, then we won't be able to see that line anymore. So try to always lay out to the inside. But we'll create a reference mark on that line. This can be the front of our booth, the back of our booth. What we're looking at is this is our corner intersect from our wall to our width, our end walls. That's what we're going to reference there. You can measure down that mark. You can mark the other end of the booth, right? So I got a length of booth, 20 foot. I measure down 20 foot. I know my booth's going to set between those 2 marks. And our second line is the one that takes a little more. This is the one that we're trying to make our right angle with. So we're just going to measure out from that first line the width of the booth. Let's say that's 10 foot or so. So we'll measure out 10 foot. And then we want to make sure that we're as square as possible when doing that. So my recommendation would be to take a framing square, lay it down on that mark that you shot, take your tape measure, try to keep it running as square with that framing square as possible. And then the larger the square, the more accurate you can be. What this is going to do is this is going to try to get you a lot closer to being perfectly square than thinking that your square really moved over 6 inches or so. And once we run through our third lines, we're going to notice that we're not in square. So that dimension is a little bit critical. It's a little bit of guesswork, and you may You know, the more you do it, the better you get at it, the more accurate or close you can be to being square on the first shot. But to actually make a square a perfect 90 degree, that's the Pythagorean theorem, which is displayed there on the right corner, which is some people call it 3-4-5 method. And what that tells us is the length of A squared and the length of B squared is going to equal the length of our long diagonal on the square. So just kind of laying that out a little bit, we'll kind of go through that. So say from our reference mark, the first one we made, we're going to set it to the 5 dimension. Now, I don't want to get too crazy into this, but anytime you take a multiple that's the same by each one of the 3, the 4, the 5s, then that'll work. So you can take 3 foot, 4 foot, that equals 5 foot across. Or let's say our booth was 9 foot wide. We could take 3 times 3, which would be 9, take 4 times 3, because we want to use the same multiple, which would be 12, and then we'd take 5 times 3, which would be 15. So mathematically, our A would be 9, B would be 12, and that would make C 15. So if you want to work it out to where you're exact hitting the references of your booth size, that can be done. You know, sometimes you may end up with a multiple with a decimal in it. But if you start with just a 3, 4, 5 as your basic principle, that gives you quite a large square to kind of lay out, if you were thinking in terms of a framing square, a pretty large reference. So you can do it that way, or you can make it longer. The longer that you make your quote unquote 5 reference, the more square you're going to be. So we'll take that in our example. Let's take that 9 foot that we made and the 12 foot that I said, and let's say that our 5 foot is at 15. So what we would do is we would take that and from that reference points, and we're going to arc that dimension. So we would take our tape measure, set it to that dimension, and we're just going to arc it across that line that we snapped. If that line, our arc, doesn't cross exactly where we made our mark originally when we laid out our second line, then we're not square. So if we come in and I arc inside of our mark, then that tells me that my line is open. If we come in and scribe to the outside of that mark from our reference line, then we're going to have a corner that's closed. So this is a trial and error type method. The better you are laying out that second line, the straighter you are with that, the more accurate you're going to be. So then you're going to have to move it slightly, re-snap your line, and then until your arc intersects, and you know that you have a square corner. Now, from that square corner, that's your right angle. You're going to have to flip that over to that again for the opposite corner of the booth. You're just going to repeat that. That would give you a 100% square booth. Now, I know there's probably guys out there that are really, really good at this, and there's probably some that it would take a half a day to do. I prefer the tech school method that I brought up. It never failed for me. Laid out very large equipment. Didn't have a whole lot of expensive equipment to do it with, and a couple $100 laser, and I was able to do it. So we'll go through that as well. It's a little faster. We'll take that same measurement off that wall that we said we're going to go 3 foot. We're going to snap that line down. We're going to say our boot's running parallel again, so down the length. We'll create our reference mark just like we did before for one of our corners. We're going to measure down that line and create our other corner. So if our booth length is 15 foot like we used just a second ago, we'll have a mark 15 foot from it as a mark, and that represents our sidewall. So this is where it changes just slightly, but what we're going to do is we're going to set our laser. And I'm talking about a 5-way laser. It could be a 3-way horizontal laser, but I recommend in your toolbox to have a 5-way laser, self-leveling laser. Not only can it help you lay out your booth, but it also can shoot you a layout line for roof penetrations that'll be plumb, and the use of a plumb bob are not needed. It really speeds up the process. It's a one-man job now instead of 2, and things like that. So I'm speaking on the lines of a 5-way self-leveling laser. You know, a couple $100 is I think what I had spent in mind. Worked perfectly, and I'll explain why that's true. So what we're going to do is we just want to align our laser. We're going to set it on that mark, and we're going to shoot it down that line that we that we've already popped on the ground, our long length line. And this is where our rafter square comes into play. So what we want to do is we're going to take our rafter square, we're going to set it right on our line, and we're going to adjust our laser until we split our dot, because we all know that if for a couple $100, we're not going to buy a laser that shoots a 16th wide dot for 300 and some odd feet. So it's going to distort. If the area is dusty, that dot's going to distort a little bit more. But as long as we take and we can visually split that dot in half, so half on our square, half off our square, that's a straight shot, because the center of that laser is the center of that laser unless you're bouncing it off mirrors or through water, I guess. So once you've done that and it's still on your reference point, which is critical, then you just want to shoot that out past the booth, the width, right, where we normally pulled our tape and said 12 foot. You can pull a tape and mark that. But that laser is going to be shooting us a right angle. So we went from our first line with our square. We're going to walk around. We're going to lay out our corner. We put our square down on that mark that we just made, right? And then we say, okay, there's my line. We mark that. We pop our line. That right there, guys, is a 90-degree angle. As long as we were on our reference mark and we split our laser down on the other end of our booth with our rafter square, we just made a right angle, right? And that's what I say, that's our third mark. So for the third line, we're just going to do the same thing to mark the other one. We're going to walk back to that second reference point where we put our square the first time. Then we're just going to shoot it back the other way. That's going to give us exactly the same thing again. Then all we have to do is just measure down those lines, and then that'll pop our fourth line, which will be our other sidewall. So we had really no trial and error. We laid it down. We shot it right the first time, and we know that we're 100% square. So I hope that made sense for y'all. So we talked about laying out, building penetrations, plan, a build plan. This is part of our build plan, because a roof penetration it's something that possibly you could be doing, or possibly another contractor or the end user customer can be providing these roof penetrations. So with our approval drawings, while let's say you're the main guy and everyone else is inventory and going through down stacking, unloading the truck, things like that, you can go through, once we've laid our booth out, we can look at our approval drawings and we can locate roof penetrations. Like I say, if it's a standard booth, we don't really know a lot about the job site. You may not have exact dimensions, but looking at the drawing, following the bill of material, you're going to be able to get very close to where these roof penetrations are going to be. From the very beginning of a job site, if we can get close, when we can recognize, there's no way this duct is going to go through this area. I got gas lines in the way. Things of that nature we can discover now, because if we're going to need offsets and they weren't already provided because we knew that we needed offsets, then those are lead times associated with those things. So if we can get that laid out, not only do we mark a penetration so that someone else can do that penetration, but we've also recognized the fact that we may need an offset. Wall penetrations are almost exactly the same way and the same reason. If we have an ANU that sits outside that has to go through the wall to reach our booth, sometimes there's building obstructions. There's, wall girts that are actually at that elevation that was unaware. There may be utilities or, any other type of conduiting or, something like that that's there. The earlier we discover these things, the faster we can come up with a solution, the less likely that you will be delayed on your entire project. And then this is just a verbal written out, right? Because we want everything done before we need them to be done. For us to be efficient installers, we need to have no stoppages. We need to be able to run from start to finish with our pace and our schedule without waiting on other people, right? So the more that we can do up front to ensure our own success, that's what needs to be done. Like I said, the offsets can be ordered. And then, hey, let's say that there was some type of design error. Hey, the booth's too tall to fit in the room. It could have been a communication error or something along those lines, and it didn't get corrected. We see those things early before we actually start a whole lot of work, have a chance to remedy those things. There's some other things to look out for when we're laying out our booths, other booths, right? A lot of times facilities, they have a booth, they want to increase their production, they want to throw up another booth right next to it. What's around us? Can we get there? Ovens, there are requirements for national codes for distances between open flames, which is what, most ovens run, and paint booths. Overhead cranes, a lot of times a sales guy won't recognize that an overhead crane hangs down below the rail and it has a hoist and a trolley and all those things, and we have a booth that, is going to interfere with that. Some other things to keep in mind is, like I say, existing utilities, existing ductwork, subgrade pits. Concrete guys, I love them, but, they don't always lay things out in the way that they should. We can check to make sure all those things are in the right spot. And then, like I say, make sure they even fit inside the building. If you install long enough, you're going to come across a job to where you get there to install something that's larger than the area that it can go in. I promise you that it will happen. Catch those things before we start building, right? Then we can save our schedule, save unnecessary workload, save having to back charge your employer or whoever, is hired. Back charges are, tough customer relations as far as employees and contractors, right? So anytime we can eliminate those types of things, we want to try to do that. So to starting construction, then we have some things we need. We need tools, we need equipment, and we need a building plan. And I'm hoping if you take anything out of this, you're going to realize you need a building plan. So I just have a list of some basic tools, right? I mean, we all know that we're going to need tape measures and wrenches. And for a spray booth, they're bolted together on 6-inch centers, 5/16 hardware, so that would be 1/2-inch tools, sockets, wrenches, things like that. Structures bolted together normally with 1/2-inch hardware, so that would be 3/4 inches for tools. We're going to need possible drill bits. We might have some holes that were not punched. In the unlikely event that they're in the wrong configuration, we may need a drill, so we'll need the associated tools for that. Depending on type of booth that you're building, ladders are utilized. Larger equipment, larger booths, we get into a lot more equipment, lifting equipment for our personnel. We get into scissor lifts, man lifts. Our fork truck is there because we're going to need to unload it, move things around on the job site. But we may need an extended forklift, and what I mean there is a telehandler, a Skytrack, Lowell, whatever you'd like to call it. We got a booth that's like some of those we looked in the picture. They're 20, 25 foot tall. Obviously, a normal 5,000-pound fork truck is not capable of lifting our beams into place, so we would need something a little larger for that. Hopefully you're aware of that project before you got on job site, that was the type of equipment that you were going to utilize or need. But scissor lifts are probably the most efficient way to build a spray booth. A lot of times man lifts have to be used just because of the requirements of the job site, to where we can't access with a scissor lift, or we're having to reach over and things like that. Ductworks, things like that sometimes utilize some type of man lift. So generate a building plan, guys, is the first thing we need to do before we ever start standing material. We need a sequence of erection. So how are we going to build this booth? Where are we starting at? What's the obstacles between that gets me from where I'm starting to where I'm finishing? We want to look for tight spaces. And I say we want to mentally install all the equipment, because what will happen is we'll get there on the job site. We know we have to build a booth, and we'll see that we have some issues, but we'll think we work through them, and we build our booth, and then we get to the end and we realize, oh crud, I got to run 60 foot of ductwork to get out of the building, and I just built my booth and I can't get to it. So now maybe possibly you're having to rent a 120 foot boom man lift at thousands of dollars a week. On something that could have been handled off of your scissor lift that you had there for, $150 a week, right? So I say all equipment because I did it. A lot of people do it. You forget about the duct work, the things on top of the booth that have to be done, electrical. If you're doing the mechanical and the electrical installation, you need to think through, once I build this, I'll be able to get into there to wire lights, to wire fans, and then obviously, try to help your fellow workers out as well if you're not doing the electrical. If we get a good build plan, we know that that's going to be a tight spot. That's going to be a time where we need to work together to make sure we all stay on pace and things like that. And then take those prints, if you haven't had them already, just take them, study through them. Everything should be there that's on that piece of equipment. Look through those things. Make sure you don't have an understanding of what the booth in your mind should look like versus what it actually looks like. See the way that the panels go together. They're sometimes with job site restrictions, we don't build exactly the way we want to. We have to change it up a little bit. The more we know about the way the booth's put together, the more we understand how it's laid out, the better plan we have to, number one, be able to overcome that issue, but number two, don't build ourselves into a place to where we become, locked in, where we start losing time. We got 4 guys standing around the job site while you're scratching your head because you don't know exactly how to approach that, right? As the crew leader, foreman, this falls under your responsibility to keep an efficient crew. And the more you know about what we're doing in the build plan and start to finish works and percentage of completions per day or time, the more efficient your crew is going to be. And then they're not standing around while you're scratching your head trying to figure these prints out or making phone calls or things of that nature. So once we figured that out and we think we got a good build plan, part of our building plan is most of these booths have plenums in a corner. If we can get to them and start with them, any cross shaft wheel, side downs are going to have a side plenum, so they really don't help us a lot. Downdrafts, obviously, no plenum in our wall structure. So we want to try to build from a corner. So in those designs, if we do have an exhaust or an intake plenum, if it's pressurized cross draft of some type, and that's where we're going to start, we can start with those units. Those units are normally 4 to 5 feet in width, and they honestly can, once they're put together, are a very structurally sound part of our booth. What it does is it gives us a place to build from. It's hard to start in the middle of the booth and start standing panels without something holding them. If we don't have those, most of the time there's some type of structure in the corner. If there is, we'll take that corner, lay it on our reference mark. We'll go ahead and anchor that corner down, build us a nice square plumb starting point. Once we start laying panels on it, that just becomes stronger and stronger. So we want to build from a solid position, something that's going to hold itself up, something that you're not running 3 or 4 lifts up against, violating all kind of safety rules, or you got guys on ladders trying to hold things up so you can build a whole section of booth to hold it up. So we want to try to build from something that's self-supporting. Corners are obviously great self-supporting areas. We build it from the ground up. Go to your opposite corner, build that corner from the ground up as best you can, tie those two together. Once they're tied together, become very stable. Something that's unstable is going to be, number one, hard to build from, unsafe. You don't want guys getting hurt on the job site. And then a solid unit does not mean tightened. Guys, these spray boots are bolted, like I said, on 6-inch centers. That's vertical and horizontal. If we take those and we build that, and we got it all stood up, and we go, okay, let's tighten that dude down so it doesn't move. What happens to us is I doubt the concrete was 100% level, probably. And we have slop in our hose to allow for things like that. So our booth may have shifted in those slots. You tighten them down. We go to build our booth. We get about 20 foot away from where we started, and our booth really needs to kind of twist back the other way. If we leave everything hand tight, don't tighten it down mechanically, then our booth has an opportunity to flex or to twist as the demands of the floor. You know, we can handle in our design, we can handle a pretty good bit of gradual decline or incline in a concrete because of the vertical seams, because of the slots in those holes. 5/16 hardware, it has a 7/16 slot, and it's 3/8 wide. So we have a little bit of play in those holes, so we can handle a pretty good gradual slope. But if you tighten those up, there's no flex anymore in those panels. That's a rigid connection. Your panel might be floating when it shouldn't be, things like that. You know, they're not going to line up. You're going to end up coming into positions where you're going to have to drill booth holes and things like that. So once we get going and we've studied our prints, we looked at the design, you know it's in sections, we get a good deal. It's kind of repetitious. This is one time when a draftsman actually helps us out by what's easiest for them, right? As installers, we know that draftspeople and design engineers sometimes don't think about us on the other end of it. This is one thing that they don't think about us, but it helps them, so it helps us. So the booths are repetitious as much as possible. Sections are going to be identical when sections can be identical. Walls from one side of the booth to the other are going to be identical to each other or mirror images of each other. If we can recognize those patterns, right, that's the faster we can install. One of the slowest things in the world is a guy going, looking at the print, grabbing a panel, putting it in, going back, looking at the print, grabbing a panel, going and putting it in. A little tip on that, when I have a crew that's not real seasoned and they're new, I lay my booth out, I look at all my sections, I take a piece of tape, I lay it on the floor, and I number out all the panel numbers on that piece of tape with the tire channel and the panels. I just write them down, just their numbers, so that all these panels have barcodes on them, or they're going to be written with a marker identifying what number of panel they are. So your guys can go, once they've already inventoried and sorted all the panels, they should all be organized by number because you inventoried them as such. Then they can go and grab them panels on their own. It doesn't take a lot of print reading or things like that. Once you build one side of the wall, you can kind of look and say, okay, we're just going to duplicate that side. So there's some repetition that, if we can recognize patterns, will definitely speed up our installation, help our newer, greenhorn installer laborers, be able to be more efficient, take a little pressure off you yourself as the lead or the foreman. And like I say, once you build one, the designs are very consistent. We rarely change the way that things are built, as long as they live within a part family. And then, don't be afraid to use knowledge, previous installations. That's how I learned not to tighten a booth up, right? I mean, you learn, experience things that, well, this worked on this job, didn't really work on this one. What was different about this one versus that one? We really did this. It's really worked well. Don't be afraid to take those on to different types of installations, not just booths, but, with anything. So let me go over just some do's and don'ts just to kind of recap, and then we'll get in. If you have any questions, we'll go through those as well. So, like I say, we do want to inventory parts, guys. It is super, super important. I understand that sometimes it's not what you want to do. I figured when I did an install one day of down stacking crates and inventory and laying the booth out, just plan for that. Plan for a day. Do not wait until the end of the project and then look for parts. You're missing a product door for some reason. Well, that's the last thing you put on. Well, guess what? You thought you were leaving tomorrow. Tomorrow you're not leaving because that's going to take a week or two to get built, right? Lay out all the aspects of your install. Start that build plan. Start mentally thinking about what we want to do. Where we're going to start it from. Don't wait until it's time to run your duct like we talked about. and then realize, oh, crud, I can't get to there. You know, don't wait until it's time to wire the lights and realize, oh, you know, we didn't really think that through, and I wish we wouldn't have shoved this booth up against the wall. You know, generate a build plan. Guys, build plans are great. What it does, it gets your mind thinking about what you're actually going to do from start to finish. Not saying that once you create that build plan, you're going to 100% stick to it. It will be revised as you move through. But try to keep that build plan. It can be a formalized as much as a document, or it can be a, hey, this is the steps I'm going to take. It'll greatly help your success as an installer, especially on larger projects, or if you're coordinating with other contractors and things like that, to get those things up front and know what you expect of yourself, your team, and other contractors. And, you know, don't build yourself into a corner, right, or block out work. You get on a job site, you're building, blowing, and going, and the electrician shows up and says, hey, whoa, I got to be able to get in there and do X. And you're going to have to stop. And we all been there. You've been installing long enough, it's going to happen. And then you're trying to figure out what you're going to do with your crew while he's back there, right? Build plan up front, gathering everybody, helps us move through that. Study those drawings best we can. Away from the job site. I say away from the job site so that you're not standing there trying to figure it out while your crew's looking at you. You know, we do not want to build sections and just bolt them to go back and do it later, you know, because say we put in panels, bolt them up, and, well, there was a plenum that knifed into there, and we didn't really look at all the drawings. We didn't see that, and now we got to go back, unbolt that whole section, slap that panel in there so we can keep going, right? Try to find you a self-supporting spot of your booth to begin your installation, something that's rigid, something that's foundation is solid, and then, you know, it's hard to work for something that's non-square and moving. That's why I say when we lay out that booth, if we lay out our booth unsquare, as we build and we go to put the roof on, we're going to realize that none of the holes in our panels are lining up. And you're going to say, well, we got to drill all those holes out. But honestly, the holes probably in the right spot. But being that our booth wasn't square or it's not plumb or something along those lines, our bolts aren't lining up. And that goes into right here. Try to line those holes up before you drill them. I know it's easy to say, dadgummit, these holes are in the wrong spot. But always try to think to yourself as a first priority, what did I do that could have possibly caused these holes to be off? Is my panel upside down? Maybe my hole pattern on my panel isn't even. Generally, we try to stick with standardized bolt patterns. They start at 3 inches from the edge, they end at 3 inches from the edge. There are some instances where the panels are not made in multiples of 6, so they might start at 5 and end at 1. If you take that panel and put it in upside down, obviously those holes aren't going to line up with the holes next to them. You know, am I square? You know, maybe I have a section, my concrete sloping off for one structural member and it's sloping the other way for the other. That puts a pretty good twist in our section. You know, work through those things. You'd be surprised what a drip pin can do by putting it in your hole of your panel and in your structure and just pulling it over. Yeah, you would be surprised. Another reason why we don't want to tighten anything. So like I say, don't just drill them. Leave them hand tight. We just talked about that. You know, if we tighten them as we go, it makes it tough. That's that much flexibility we take out. Now, yes, there's going to be instances in our build plan that we know we're in a tight area. We're going to have to do some things. And if we ever do have to tighten up things before we can move forward, we make sure that we are square, when we are plumb, and everything is lined up as it should be, not just as it's resting. Because it can be resting, standing, but it can be resting out of plumb. So we need to make sure everything is in plumb before we tighten those things in those instances. Biggest thing, guys, take pride in your install. Take pride in what you do from start to finish. You know, it's a great accomplishment to go on a job site and think through what you want to do and build a build plan, and your crew's there and you work very efficiently and you finish early, or you work through and you have no issues. You know, it looks great. Customer comes up and says, man, that looks great. You know, take pride in those things, because what will happen is if we don't generate a good plan and we don't inventory and we don't, you know, look for obstacles and things like that, what we end up with is a just hurry up and finish approach. And what that is I've been on the job site too long. I only figured for 4 days. We've been here for 5. We got to get off this job site. So we put latches on crooked, or we don't caulk the booth the way that we should, or we send a guy to do a job that he's not really trained to do, but I need him to do it so I can hurry up and get out of here. It looks bad on you as a installer. It looks bad on Col-Met as a manufacturer, because the equipment can possibly look bad when there was really nothing wrong with the equipment. It was just the manner that it was installed, right? So I hope that helped everybody. I hope you got something out of it. Main thing is we want to make sure that you take some of these tips, some of this experience that we talked through, try to generate it into your installs. Hopefully you become more productive, more profitable. And Jen, I guess we'll open it up to questions.
At this time, if you have any questions, feel free to type them in that question box on the control panel. We'll just wait a couple minutes to see. Okay, I don't see that anyone has any questions. So if you do have a question and you want to email us, feel free to email myself, and I can send this to Trey, jegan@colmetsb.com, or give us a call. Actually, I'm sorry, we have one question that just came in. Any tips on supporting hip lights while installing roof panels?
And I'm assuming you're probably talking along the lines of an automotive structure or an automotive style booth where the support structure is more of a hockey stick design than an actual structural member. To be honest with you, that's a tough one because of the way that the booth is designed. What I have seen in the past, I'm not the expert on these types of booths, or they're kind of out of my realm of installation because of their size. But what I've seen in the past is 2x4s being used in the hip hole to hold that panel until you can get that next structural member stood to help hold that hip up while you're trying to build out that way. I've seen material dollies be used, as in like sheetrock dollies, things of that nature. What I've done in the past is I've actually taken some tie channel that was for the wall. Now obviously you can't use it the whole time, and I bolted it across there to try to hold those open as well. I hope that answered your question. I know it's not a great answer.
All right, and at this time we don't have any other questions, so like I said, if any other questions come up, just feel free to email us or give us a call, and we can help you with that. Otherwise, thank you, Trey, for the presentation, and thank you to everyone that joined us today.
Yes, thanks a lot.
Thank you, guys. Bye.